So I'm going to work through some problems like the homework, and it all basically comes down to this information when you're plotting trig functions, sine and cosine functions. One is you need to know what the amplitude is, you need to know what the period is, and you need to know what the horizontal shift is. And so a lot of the time the equations are given as in a form of some constant a, which can be plus or minus. Well, a is positive, but then you can have a plus or minus sign out in front of it. A is the amplitude, so amplitude is always positive. Then you have the sine or the cosine, doesn't matter which. And then you have some constant a times x minus b. But if you factor out the a for the two terms in the parentheses, you get a times x minus b over a. And you can use a to find the period. That's the time or the x value to go one full cycle through the sine function or the cosine function. And that's equal to, the period is equal to 2 pi divided by a. So if a equals 1, which is the simplest case, then the period is going to be 2 pi. You go through one full cycle of values from 0 to 2 pi, just like we do when we look at a circle, unit circle. And then the horizontal shift I'm going to call phi, which is a Greek symbol. It's also called a phase. It's called a phase shift, phase angle, and that is equal to b divided by a. So let's look at the problems now, the kind of problems that you'll have. So the first bunch are just looking at amplitude and period. So for example, let's say I have y equals 3 sine of 2x. So we look over here at this and we say, okay, the only thing I could do is I could factor the 2 out, which doesn't, you don't really need to do that. It's like, and put a 0 in here just to show that there's no shift base compared to the normal function. And as a consequence, the amplitude is going to be 3, and the period, a is 2, small a is 2, so the period is 2 pi divided by 2, or it's going to be pi. Now here they're just asking for the amplitude and the period, so the answers for this problem are a equals 3 and period equals pi. But I'm going to go into a little more detail because it will help us when we get further on in these problems. So what we'll do is we'll draw a rough sketch, and then we'll plot it using a graphing program. So what you have to think about is the parent function is the sine of x. And the sine starts at 0 and goes up to positive 1, goes back through 0, goes to negative 1, comes back up to 0. Now the only difference between this one in terms of the time it takes to do one oscillation is it happens twice as fast. So instead of going from 0 to 2 pi, we go from 0 to pi. So we have one full oscillation. And so we break this up into these 4 parts. Now normally we have 2 pi, pi over 2. So what we would do is we'd break this up into 4 parts. This would be pi over 4, pi over 2, 3 pi over 4. So this is 1/4, 2/4, 3/4, 4/4. Now the amplitude is 3, so that means we're going to go up to 3 and we're going to go down to -3. So we start off at 0, we end at 0. Halfway between we're 0. At the quarter point we're at the maximum amplitude of 3, and at the 3/4 point we're at the negative amplitude. And then you just have to sketch in what looks kind of like a sine function. Okay, so we should hopefully have the idea what a sine function kind of looks like. Has this awesome, this characteristic behavior. So that's what this function looks like. Amplitude of 3. That's this distance from the midpoint to the maximum, as well as from the midpoint to the minimum. Both those are a. And the period is how long it takes to make one full oscillation. Okay, let's look at another one here. So let's say y is equal to 1/2 the cosine of x divided by 4. Again, we can kind of put this in standard form. So we got 1/2 the cosine, and what we do is we'd factor out a fourth. So you have a fourth times x minus 0. So there's no horizontal shift. So what we have is the amplitude is 1/2. It's this number in front, absolute value. So it's really the absolute value of 1/2, which is still 1/2. And then you have the period is equal to 2 pi divided by a, but a is a quarter. So we get 2 pi divided by 1/4, which is 8 pi. So the period is 8 pi. The amplitude is 1/2. So how does this thing look? So we can. Oh, and I forgot to plot this just to show you that it's right. So let me find my graphing program. And what we'll do is we'll change the view. You can't see this, but we're going to change the view to, oh, it is a multiple of pi. Okay, so everything's good there. And we're going to plot. And we're going to plot the function 3 times the sine of 2x. And the minimum is going to be -3. Oh, that's the x value. The x value, we're going to go from 0 to pi, because that's the period. And we go from -3 to +3. And if we graph that, it looks just like that. So you can see it matches up with what I had. The period is pi. Half the period is pi over 2. Fourth of the period is pi over 4. And the amplitude is 3, so that matches up exactly. Okay, so now we're going to do the next one, which is same kind of deal. Now the amplitude is 1/2, so I'm just going to put 1/2 here. And we'll put a -1/2 there. So we're adjusting our y scale. Now, a period is 8 pi. So instead of putting pi here, that was the period over here, we put 8 pi. So half of 8 pi is 4 pi. And then the quarter point is 2 pi. So it's 2, 4, 6 pi. Now the cosine function at 0, it's equal to the maximum value. And at 8 pi, in this case for the full period, it's equal to the maximum value. And then halfway between, it's equal to the minimum value. And then the other values are 0. And again, you can now draw this characteristic looking function to be like that. And again, what we'll do is we'll look at this graph. What we'll do is we'll change it to 1/2 times the cosine of x divided by 4. And we said that the period was 8 pi, and the minimum was -1/2, and the maximum was 1/2. And it should look almost exactly the same, except it'll look like the cosine function. So you see here it starts at the maximum, goes to the minimum, goes back to the maximum, goes through 0, and you can see how it matches up with that. Okay, I'm going to do one more example here. These are just again dealing with periods and amplitudes. So let's say you have y is equal to 2 times the sine of 2 pi x. So now instead of just having a constant, I've got this 2 pi in front. So the amplitude is the absolute value of the term in front, and then we have the sine, and what I'm going to do is factor out 2 pi. So it's 2 pi times x minus 0. So again, there's no horizontal shift because there's no term added on in the parentheses. And I don't know why I combined two things here. I was thinking about two things. Let's just... Okay, so the amplitude is still the absolute value of 2, which is 2. And the period is equal to 2 pi divided by a, and a in this case is 2 pi. So we get 2 pi divided by 2 pi, so the period is 1. So if I were to plot this, again I'm just going to plot one period. So the period length is 1. We start at 0. Half of 1 is 1/2. 1/4 of 1 is 1/4. 1/4, 1/2, 3/4. Then we plot the magnitude here, the amplitude. So this is +2 and this is -2. And then we look at the sine function. Well, the sine function starts at 0 at the beginning of the period, 0 at the end of the period, 0 in the middle of the period. Its maximum value is 1/4 and the minimum value at 3/4. We can draw this sine function looking thing through here like that. So if we go to our graph, what we do is we change the period from 0 to 8 pi to 0 to 1. The minimum value is -2. The maximum value is +2. We graph, and one thing we have to do here is we have to, obviously done something wrong, but first we're going to change the view to not be part of pi. Let's go back and see what I did wrong here. 1/2 cosine of, oh, it's because it's equal to, I said 2 pi x. 1/2, and it should be, I didn't change anything here. I didn't change my equation. 2 times the sine. 2 times the sine of 2 pi x. And there we go. So again, we go through one full oscillation from 0 to 1. We start at 0, we end at 0, we have a 0 in the middle. Our maximum value is at the 1/4 point and the minimum value is at the 3/4 point. So all I've been doing is changing the scales to make it look exactly the same. Okay, the next group of problems, similar to this, except it asks you to plot them, which we've already been doing, and it says include 2 full periods. So when here we just did 1 full period. So let's say y equals -4 times the sine of 3x. So our amplitude is the absolute value of -4. That's 4. Our period is 2 pi divided by a. That's 2 pi divided by 3, 2/3 pi. So 2 times the period is going to be 4 pi divided by 3. And so that's the that's how long I need. That gives me my extent of my x-axis. Let's look at period. The period divided by 2, divided by 4, and 3/4 period, like that. See what those are. So if we take a fourth of this, 2/3 pi divided by 4, we'll get 2/12, which is 1/6. So this is pi over 6. This one's going to be pi over 3, because 2 pi over 3 divided by 2 is pi over 3. And this will be, this is 1 pi over 6, 2 pi over 6, 3 pi. Is that right? Yeah. 3 pi over 6, which is pi over 2. And then you have the period, which is 2 pi over 3. So we're going by 6. 1 6, 2 6, 3 6, 4 6. So let's start drawing something here. So we need our axis. We're gonna do 2 periods, so that's equal to 4 pi over 3. So we go halfway. That's 2 pi over 3. Okay. And then we need to break these up into 4 parts. What we'll do is we'll do for 1 period, and then the second part we can just kind of duplicate. Our amplitude is 4, so we can go plus 4 to minus 4. And one last thing you got to think about here, this negative sign. What this negative sign here does is it flips it over the. This negative sign is an x-axis reflection. So I'm going to do very lightly without the reflection, what it would be. So it's a sine function. So it starts at 0. It goes to positive 1 here. Well, the maximum here goes back to 0. Go down to negative, the minimum. But what we're going to do is we're going to flip those around. So the negative sign makes these go the opposite direction. So we still start at 0. We come down here instead of going up there. We still 0. 0 reflect across the x-axis. Nothing happens. We go up there like that, and then we can kind of repeat what happens. So we go down here to this is 1 period apart, and then we come up to 0. Then we go up to there, and then we come back down to 0. So we could put like a kind of a boundary. This is the limits of the function. Okay, so we come down here, go through the minimum, go back up through here, go to the maximum. This kind of curved nature to it. So it goes straight, the line's straight through these points, but it has the curvature. So we don't just go straight to this point. We kind of come at it, and then we curve around as we get close to the end. And then we come back up here to there, and then we go back down to there. So you can see we go through 1 period and 2 periods. The amplitude is 4, but because of the negative sign, it gets flipped over the x-axis. So let's plot this. So what we'll do is we will go from 0 to, what did I say it was? 4 pi over 3. So that's so I can get a full 2 periods. The amplitude is 4, so I go from negative 4 to positive 4, and the function is negative 4 times the sine of, what's the number here? 3x. 3x, close parenthesis. And what we should see is something that looks just like that. So, say graph. So So let's compare those. Yeah, it looks pretty good, doesn't it? So here you can see it. This is, and we could do it as a function of pi. So let's go to change the view to x-axis. So it's you can see this is pi over 3. This is pi over 2. What was it? Pi over 6, pi over 3, pi over 2. And then one full period is 2 pi over 3. And then we go through one more complete oscillation. So that's why we learned a few things there. We already knew how to get the period. We said, okay, the extent of the plot is 2 periods. So that helped us define the x, how much x-axis we need to show. The amplitude told us what to set our y-limits at. The negative in front of the whole thing told us that we need to rotate or reflect it across the x-axis. Okay, let's look at another one here. Let's say we have y equals 1 minus plus the cosine of 4 pi. Okay. Actually, let's add I think it's one more. Let's say it's 1 plus 2 times the cosine of 4 pi. Let's rearrange this. 2 cosine of 4 pi plus 1. So what we can say is the amplitude is the absolute value of 2. Okay, so that's 2, which is 2. That's the amplitude. So that will give us the plus and minus. We see, and I need to put an x in there. X, 4 pi x. So remember, so a, small a is 4 pi. We don't have any horizontal shift because this plus 1 is outside of the cosine function, so it's probably good to put some parentheses there. Make sure that's completely understood. Therefore, the period is equal to 2 pi divided by a, which is 2 pi divided by 4 pi, which is 1/2. Or 2 times the period is 1. So that's the, we're going to go from 0 to 1. And then this term here means a plus y shift. So we're going to shift everything up 1 unit. So let's start thinking about what's going on here. So we're going to have a function. Now it's going to be shifted 1 unit in the y direction. So instead of oscillating around x or y equals 0, we're actually going to oscillate around y equals 1. So let's just kind of draw a horizontal line here. Now, the extent of our graph goes from 0 to 1, which is twice the period. So we're going to, then when you break that into half, that's going to be a half. So we'll have 1 full period here, and then we'll have half, a quarter, 3/4. We'll do the same thing over here. Half, quarter, 3/4. So this is 1/2. This is 3/4. Now the amplitude is 2. So what we're going to do is we're going to go up to 3. So 1, 2, 3. So this will be 3. And we'll go down to -1. So the amplitude is how much it oscillates around this center point. Now we look at the kind of function it is, which is a cosine. We don't have a negative sign in front here, so we don't have any x-axis reflection. So remember, a cosine function starts at its maximum value. It goes through normally 0, but because of the shift it'll go through 1. Then at half the period it'll go down to its minimum. It'll go back up to 0, I mean the midpoint, and then it'll go up to the maximum point. So that's one full period, and then it repeats itself. So here it goes to 0, here it goes to -1, here it goes to 0, here it goes to +3. So you see how all these things repeat. And again, you have this curved nature of the program, of the function. So it'll go down like that, through there, back up through the midpoint, down through here, there, back up, like that. So let's go back and review. I moved this to the end. That's my Y shift. Therefore, I moved the center point of the oscillation to 1. I took this number, 4 pi, put that in the denominator. That gave me the period for one oscillation. So I doubled that to get 2 oscillations. Then I went back to the 1 full oscillation, broke that up into quarters. For the cosine, the beginning of the oscillation is the maximum value, then it goes to 0, then the minimum, 0, maximum. That's one full oscillation. Then you do the same thing. It just keeps repeating itself over and over and over again. Okay, so now we're going to graph it. So let's go back and fix this. First thing is we can change the x-axis to just integers. The minimum x is 0, the maximum x is 1. That's twice the period. The y minimum would be -1, and the y maximum would be 3, with a center point of 1. And the function is 1 plus 2 times the cosine of 4 pi x. Make sure I did that right. 1 plus 2 cosine of 4 pi x. And if I have this right, it should pretty much look exactly like I've got here, except it's gonna start off at 3 and then go down from that point. So there you see. So here it goes. So 3 goes through the midpoint here at 1, goes down to a minimum, -1, goes through the midpoint here, 1, up to the maximum, 3. That's one full period, does it twice, and you can see I've got 2 full periods. So that's how you handle a Y translation. Okay, this one's complicated, like number 9. So I'm gonna do. Now I could put a negative sign in here, but I don't want to. Well, no, I will put a negative sign here, so because you'll need to know what to do. And let's do 3. So it's -3 times the cosine or the sine. Let's do the sine. I'm trying to not do exactly like you have for your homework. -3 sine of x plus pi over 2 minus 1. Okay, so we got a lot going on here. You notice this is my y shift. So that means that everything's going to center around -1 in the y direction. You can see that my amplitude is equal to the absolute value of -3, which is 3. This means x-axis reflection. Now here, what we have is, let me just rewrite this a little bit. So if I factor out a 1, I'd have 1 times x plus pi over 2 minus 1. So you're like, why did you do that? Well, this just, I wanted to get it in standard form. So a is equal to 1. So the period is 2 pi over a. So So the period is equal to 2 pi. Therefore, twice the period is equal to 4 pi. So that gives me, this gives me a feeling of how much in the y direction I need to have space. This tells me how much I need to shift it. This one tells me how much x-axis stuff I need going on. Now, I've got this one additional thing. So let me pull that down here. What this term here says, I have an x shift equal to negative pi over 2. Okay, let's see if we can put all this together. So this is shifted in the y direction by 1 unit, so I'm going to kind of offset this a little bit. So here's negative 1. So let me just draw a horizontal line. Okay, so that's where everything's going to oscillate around. Then I've got an amplitude of 3. So I go 1, 2, 3. So the maximum is 2, and I go the other way. 1, 2, 3. So 1, 2, 3. This is negative 4. So let's draw a line in. That's how the function is going to be bounded. Okay, now the distance in the x-axis, 2 times the period is pi over 4, so this is 4 pi. So this is 4 pi, that's 2 periods. Cut it in half, 2 pi is 1 period. Pi is half of 1 period. Then you have pi over 2, you have 3 pi over 2, and you have similarly broken up there. I'm not going to write the numbers down. I'm just going to kind of repeat what's going on here. Now the sine function is going to normally be 0, max, 0, min, 0. Okay, so I'm going to just draw that in there. So if I didn't have the negative sign and I didn't have the pi over 2, it would look something like this. Actually, it would go to maximum here, and it would come through this midpoint, so it would go down like this, and then all the way down to a minimum here, and then it would go up to 0 again right here. So these zeros here, they're not really zeros, but they're okay. So that's what I'm showing there in the black would be y equals 3 sine of x minus 1. So you get the amplitude of 3, you get a period of 2 pi, you get a y shift of 1. So what's going to happen now is you're going to, this pi over 2 shift means that this is going to get moved back. So now that point is here. So this maximum, which occurs at pi over 2, and that's now going to happen at pi. This one here gets moved to there. Well, actually, this one here gets moved to there. Let me erase that. So this crossing point moves. This point moves to here. This crossing point moves to there. And this maximum moves to there. So you go max, 0, minimum, 0, max. But then you flip it over the x-axis. So this max goes to this minimum right there. This 0 point stays the same. This minimum goes to the max point here. Then you go back through 0, and then you go down to a minimum here. So let's just draw this in. So it's going to have this sine looking, this oscillating looking behavior. So it goes straight through here, but then it loops around and then comes back down here and then goes to there. And then you can repeat everything. So this next quarter period we go to there, next quarter period we go up there, next quarter period we go there, next quarter period we go down there. And so this thing just repeats itself like that. And then that goes all the way down to here. And so the green curve is the final answer. So let's repeat what we did here. One is we put a horizontal line at the y shift. Then we took the amplitude and went up the amplitude and down the amplitude from that midpoint. We set the x-axis based on twice the period. Then we took half of that to get the one full period. Broke that up into 4 points, 4 parts: quarter, half, 3/4, full period. We looked at this without the negative sign. We know a sine wave starts at 0, goes up to the max, goes down through the midpoint. So this actually needs to go. I need to get this down to here. Not to there, but to there. It goes to the midpoint. So that's the normal sine function. Then what we did is we shifted this pi over 2 units to the left because it's x minus shift. So it's a negative shift. So we got that point, and then we did the minus sign here, which flipped it over to the other side, and this one flipped over to the other side. And really you just need these 4 points. You need 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5 points to get a whole cycle. That's really all you need once you know the shape. So we're going to plot this thing, but the first thing we'll do is we will change the view to be some multiple of pi. We'll go to our graph. Our minimum value will be -4, and our maximum value will be 2. Let's see, that's what we had. Minimum -4, maximum 2. Oh, that should be on the y, sorry. -4, 2, okay. Our minimum value is 0 for x, and our maximum value is 4 pi. And my function is -3 sine of x plus pi over 2 minus 1. Let's double check that. -3 sine of x plus pi over 2 minus 1. Okay. And what we should see is something that looks like that. Start down here, we'll go up to a maximum and through that. So let's get this shot here, graph. And there we go. So you can see, looks just like the green curve. So if we would plot a curve which was y equals -1, which is the midpoint, you'd see how this function has been shifted down. And notice how at pi over 2 it goes to 0, at pi it goes to the maximum, pi 3 pi over 2 it goes to 0, and at 2 pi it goes through the minimum and matches everything up correctly. And I just realized I skipped over some examples for like 4 and 5 in the homework. And those were talking about horizontal, somewhat with horizontal shifts, but I think, so let me just do an example. So let's say f of x equals the cosine of x. That's kind of our parent function. And then you have g of x equals the sine of x minus pi over 2. So what we're considering is well, let's say it's 2x minus pi over 2, and you want to know what the shifts are. and the periods. So again, what we would do in the second case is we would factor out a 2 for both parts. So you'd have x minus 2 times x over 4. Yeah, pi over 4. So if you factor out a 2 here, you'll just get x. And if you factor out a 2, which means dividing by 2, you get pi over 4. So what we see is that a is equal to 2, small a is equal to 2. Therefore, the period is equal to 2 pi over 2, which is pi. So the period is pi. And the shift, here we have x minus h. So in this case, the shift is positive. H is positive pi over 4. So that's my x shift is pi over 4. So that's basically how that works. You've got to make sure that you don't just say it's pi over 2. You have to factor out this 2 out of both parts to get it correctly, to get the shift correctly. And that's because, you know, the period here is reflected in this number. And if you have half the period, then this shift is going to cause, it's really a proportion, relating the proportions to these two. So anyway, just do it. Factor out whatever the coefficient in front of x is. Factor that out of both parts of the expression of the sine to get the right shift. One thing we haven't talked about is, you know, what happens if you have a negative sign. So let's say we have the cosine of negative 1/2 x. How does a negative affect things? Well, what that does, this is a y-axis reflection. So if you look at something like the cosine function here, because the cosine function is an even function, if you shift that over to here and you shift that over to there, it looks exactly the same. So that really doesn't affect anything. So if I did the cosine of 1/2 x, it would be the same plot as the cosine of negative 1/2 x. Let me just prove that that's true. So what we're going to do is we're going to go from 0, actually we're going to go from negative 2 pi to positive 2 pi, and we'll go from negative 1 to positive 1. So if I did the cosine of x over 2 and compare that with the cosine of negative x over 2, you see there's only one curve. It's because they're the same. But if I did the sine, which is not an even function, then it's going to look different. So let's do the sine of, and I'll explain the sine in just a second. So you get them. So what happens is this point reflects over to here, and this point reflects over to there, and this point just stays where it is. So if I had something like, you know, f of x equals the sine of 4x, that would be the same as, so if I did the sine of negative 4x, so what happens here is everything gets flipped across the y-axis. Whereas when you have the negative sign here and the positive sign, for the cosine it doesn't do anything. This is an odd function. That means that if you look at the sine function looks like that. So this flips around like that. Flips across the y-axis. And then there are a couple of word problems. So one is about sound waves, and sound waves, typically what you're talking about there is talking about the pressure of the air as a function of time, and the pressures are usually pretty small. So you'll see in the problem the amplitude is pretty small, and you can either use the sine or the cosine, doesn't matter. And then you have something like 200 pi times t. Now t is the variable because we're talking about time instead of displacement x, we're talking about time. So in this case the amplitude is 0.02 and the period is 2 pi divided by a, and so you get 2 pi divided by 200 pi, which is going to be 1/100th or 0.01, and the period for has to be seconds because you're going to have time in seconds and the period is in the denominator, so you end up having to, the argument of the trig function always has to be unitless, so that makes sense. But period, think of something oscillating, period in seconds makes sense. So sound waves oscillate pretty quickly, so it means there's 100th of a second it oscillates 1 or 100 oscillations per second. So if we talked about the frequency, that would be 100 hertz, where hertz is a cycle per second. So they ask what is the period of this function, and then the frequency, they ask for that, which is just 1 over the period. So you can use this to calculate the period and then take the reciprocal of that to find the frequency. And the second one is kind of the same thing. It's talking about pressure as a function of, well, here it's blood pressure. What they're saying is that the blood pressure is going to be some value, positive value, and then it oscillates plus or minus around that value. And it's the same kind of relationship. So I'm going to give you something that kind of looks like the homework problem, but not the homework problem. So let's say it's 110 minus 30 times the cosine of 7 pi over 4t. So what this thing looks like, you see you've got 100, this is 110, and it goes up to 140, and it goes down to 80. So this is the amplitude is 30. And at t equals 0, you're going to have the cosine of 0, which is 1. So you start off here at 80. Now in terms of the time, what you have to think about is a, in this case, is 7 pi over 4. So the period is equal to 2 pi divided by 7 pi over 4. And the pi's cancel out. And then you take the reciprocal of 7/4, which is 4/7. So 2 divided by 7/4 is the same as 2 times 4/7, which is 8/7. So it's 8/7 seconds per period. So this guy's going to have a heart rate of less than 60 beats per second. So what we have is 8/7 beats per seconds per beat. Or if you take the reciprocal, you'll have 7/8 beats per second. So if you want to find the number of beats per minute, you just say 60 seconds per minute. So 7 divided by 8 times 60 is 52.5 beats per minute. So this all comes from the original expression. They're, because they're only asking for the period and the number of heartbeats per minute, you don't really, the rest of the equation is kind of immaterial. The only part that's really has relevance as far as answering the questions is to use this A in front of the T to find the period. Once you have the period, then you can, the frequency is 1 over the period. So that was what we did here. Frequency is 7/8 beats per second. This is seconds per beat. This is beats per second. And then you have to convert to minutes.